This is our speaker today is Bernard Avishai. I pulled your biography, including the horrible picture off of Wikipedia. I'll just say one or two things about Bernie, who lives not far from me in Jerusalem. First of all, I'm a little scared of him because he used to run a similar program at the Interdisciplinary Center in Herzliya. So please don't tell him any of our trade secrets. What I really want to say about Bernie, who's done an amazing number of things, who's been with Monitor, with the Harvard Business Review, who's written a whole bunch of books, a lot of articles for the New York Review of Books, has a great blog on Israeli political topics, and I guess other stuff. So the two words that I think really typify Bernie are thought leadership, which is actually a phrase that I usually despise. But in his case, it's actually totally appropriate. A person with enormous range of interests and knowledge and thoughts, and somebody who both his books and his articles and his speeches have really sort of broadened other people's approaches to things. So that's pretty nice to say about somebody,
that's
right?
very nice.
And all the rest is bullshit.
Yeah,
right?
I think you should stop.
I should stop. Okay, so here's Bernard Avishai, and he's going to talk about the ecosystem of entrepreneurship.
Okay, so now that we have the cliche thought leadership, I think my title probably will be a contender for the world's record in other business cliches, ecosystem, entrepreneurship, revolution, and so forth. So let me start by suggesting some fundamental concepts, because I'm going to go very quickly through a big argument. The argument is readable, so if I move quickly and you missed a little point here and there, which we don't get to in questions, by all means, you can just download the cover article from Inc. magazine in November on this subject, and you'll be able to get a quieter, more thoughtful version of what I'm going to give you. But there's not, there aren't too many notions, I think, that are as overworked as this notion of an ecosystem. So why don't we start with that? Here is where I'm going to take you. I'm going to make the argument that the electric car is really a mobile device. I would want to say the ultimate mobile device, but, you know, the word ultimate is probably not a useful word for somebody who's going to die, and that's me and you. So let's not say ultimate mobile device, but at least for the foreseeable future, it's the ultimate mobile device created in a network, that is to say, created in a supplier network, which is now typical of the auto industry in ways that were unprecedented only 20 years ago. And it's created for two other networks, an electrical grid and an information grid that governs the movement of electrons and bits from the electrical grid and from the information grid, and brings them down to this mobile device just the same way you will now, in effect, you know, download an app from iTunes. Now, I know that's a lot to take in, but I think it's also sort of intuitively obvious when you think about it. So if you're having this sort of weird reaction, which is that on the one hand, you understand exactly what I'm saying, and on the other hand, you don't know what I'm talking about, don't worry. That's normal. First of all, what do we mean by an ecosystem? The word ecosystem is actually, again, one of those intuitively obvious ideas which Jim Moore finally gave voice to back in the Harvard Business Review in 1993, just after I left, actually, but I knew him well, and he's a very thoughtful guy. And basically what he was saying is this, that we have to begin, now that we have networks that are bringing businesses together, we have to start thinking about businesses co-evolving. Now, that in and of itself is not the most revolutionary idea. I mean, businesses always had suppliers, and you always had networks, or at least you could use the metaphor of a network to talk about how businesses created relationships with one another, right? Ford had its network, as it were, of businesses that were supplying it even in the Rouge River plant. Stop me if I say something you don't get, right? I mean, everybody knows what the Rouge River plant was. Maybe you don't, maybe not. Stalin knew what the Rouge River plant was. Okay. Who was Stalin? Right. Lenin knew. You mean from the Beatles? No. So we knew we had networks, but they were not actually self-consciously connected and exchanging information the way information networks have allowed them to become. The original idea of an ecosystem in 1993 picked up on this idea that businesses could co-evolve. And they actually depended on one another in order to have business relationships. Best example, I don't know if you can see, but GM had relationships with Eaton Industry, Volkswagen to Bosch, etc. And when you look at the auto industry, the original ecosystem was basically dominated, and this is what Jim Moore thought, the original ecosystem was going to be dominated by an OEM, original equipment manufacturer, that would have networks of suppliers with whom it was exchanging information. So the original notion of an ecosystem was consistent with what we called engineering platforms. You had, in Germany, an engineering design for the Polo, for example, which is the one step down from the Golf. All of the components would be evolved within the network of suppliers in Germany to the specifications and standards dictated by who? Volkswagen. Volkswagen designed the specs, the performance specifications. What began to happen because of these networks in the 1980s and 90s is that because the suppliers were able to get an early look at the performance specifications, they were able to what? This is also intuitive. Somebody have an idea? What were they able to do? Huh? They were able to estimate cost. They were able to improvise designs. So that the original ecosystem idea was, we are going to create a system of performance specifications. We're going to work with suppliers in our own domain. Those suppliers would get our performance specifications and then compete with one another, be rivals with one another to come up with performance specifications that were going to satisfy the demands of our, come up with technical specifications that would solve the problem of our performance specification. We'd give them the envelope, and they would fill it up. Okay? So Bosch didn't get a design for a fuel injector. Bosch got the performance specifications for a fuel injector and would compete with other companies, Siemens and others, to create fuel injectors for Volkswagen. Okay? So far, so good? So this was the idea of an ecosystem. Within the context of that kind of platform technology, you might get a purchase of Skoda. Skoda would, and this is what actually happened, Skoda was the Czech combine that was producing the best cars in the communist bloc. And the president of Volkswagen and the chairman of Volkswagen in 1990, Karl Hahn, bought Skoda, partly because he was himself a Czech German. It's an interesting kind of series of personal stories here as well. The head of Volkswagen, Karl Hahn, the Porsche family that had helped develop the Volkswagen, they were all Czechs, Czech Germans, what was called later Sudeten Germans. Ferdinand Piëch, who succeeded Karl Hahn, was also Czech. Anyway, they all knew that there was great engineering talent in Czechoslovakia, and they bought Skoda, but they had no idea of ever giving Skoda the possibility of creating cars. What they were going to buy from Skoda was engineering talent, which would take the platform, take the supplier network, and put a skin around the car, around the platform, a Czech skin around German guts. That was the idea of the platform. And it was the kind of ecosystem that was consistent with the platform world. Now, let me see if this works. The platform world actually was, to go meta on this for a moment, the platform world was consistent with what we thought of as the classical corporation. The classical corporation was a huge pyramid in which you had a division of labor, where you had command and control from the top, where you were aiming for mass markets, economies of scale. You're all in MBA mode. If you don't understand immediately what this is, you're not going to learn it from me in the next 5 seconds. But what was critical to understand is that platform technology was an expression of this kind of company, and market conditions and terms of competition that this kind of company lived in. Big company created through its R&D a platform. The platform reproduced itself in Czechoslovakia. Why? What would be the point of going to Czechoslovakia? Cheaper labor. You went to Czechoslovakia because you knew you'd get good labor cheaper. And that was the idea. Well, something happened between 1993 and today. People like Tom Friedman, describe it in terms of the flatteners that changed the world. The 10 ways that the world has been flattened. I'm not going to dwell on this now. I will say this, that the classical corporation has been changed by information technology in ways that are really still, for most of us, kind of magical. First of all, the great corporation, if you look at the great corporations, you began to have information systems replacing middle management. You began to have digital manufacturing and robotics replacing labor. And what was happening is that as that became more and more characteristic of companies, when a lot of people say that companies have been flattened and the management has been flattened in companies. That's actually a misnomer. It's not that companies have been flattened. It's what's been happening is that the bottom has fallen out. In most companies, the white-collar labor, which used to do nothing more than send instructions down and send information up, have been replaced by information systems. And the blue-collar labor, which used to take instructions and be told basically, don't bring your head to work. This is sort of the famous, Frederick Winslow Taylor admonition, just do what you're told, don't bring your head to work. That kind of labor has begun to disappear in the 1980s, 1990s. It's one of the reasons why Japan went into crisis, because the Japanese were great at disciplining huge pyramids of workers. But by the mid-1990s, they discovered that they were increasingly competing in a world where not every part of the company required a large labor force. The components that were being made in the labor force, the components that were being made for particular product programs were often less than 10% labor. A car today, which was 55% labor in the 1960s, today is about 12%. Some components still require a great deal of labor, including the final assembly, although even final assembly is less and less labor. When I visited the Volkswagen plant a couple of years ago, they had something like 50 kilometers of production line in Wolfsburg. 50 kilometers of production line. Something like 42 kilometers are robots. Robots, with one person managing and monitoring the activities of the robot. So what's really been happening is, on the one hand, the bottom has fallen out. Companies have become more and more knowledge-based. They network with one another. They co-evolve with one another, but not necessarily anymore simply because one big company is dictating the specifications. Now I'm starting to edge up into something I'm sure you know a great deal about, open source design principles and so forth. And what begins to become characteristic of the company is that you're no longer competing on mass markets, you're competing on micro-segmented markets. You're no longer competing for a division of labor. You're competing on the ability to inspire teams to solve problems and to interact with one another as teams. Right? Companies have become swarms of problem-solving teams that are connected through peer-to-peer networks. The key thing for product development is not the creation of a cost saving necessarily, but the capacity to do technical integration. Time to market innovation is more important than scale and cost. Or scale and price, I should say. All of these things are sort of intuitively obvious. I know that it's trying your patience a little bit to try to get you to all understand it in one gulp. But it's terribly important for you to understand if you're going to understand what I mean by the ecosystem of the electric car. Because you're dealing in a world which has been flattened. You're dealing with in a world where every problem-solving team in the company is now potentially connected to problem-solving teams in companies around the world that may be getting a certain amount of instruction from senior management, but may also be taking an initiative down in the bottom of the company, which they are trying to champion through the rest of the company, and they may be getting allies by connecting to a supplier or to a customer to prove a business case to senior management so that senior management invests in them the same way a venture capital firm will invest in an initiative or a company. So we're dealing now with a different kind of world, a networked world, which, if you, assume. Oh, how did I get here? let me resume with F5. So if you deal with a network world, I had a little slide I'm going to not. If you deal with a network world, you're also dealing with the network effect of a network world. In other words, the more companies come into the network, the more valuable the network becomes. You've heard of Metcalfes Law, presumably, right? It's intuitive. Why is it the case that the more companies come onto a network, the more valuable the network is? Huh? Exactly. So everybody has the chance to contribute, learn what's on the network, learn from the network. I mean, you get into problems of information overload and all that stuff. I'm not diminishing those problems either. But when you're dealing with an auto industry today, you're not any longer dealing with an auto industry in which some big company is dictating the specifications for products. You're dealing with a world in which individual entrepreneurial teams within companies may come up with an idea, connect to a bunch of suppliers, develop a concept, bring the concept to management, have management invest in them, and then be launching into a world where they are, in effect, creating an ecosystem for their components and their successes, if the product succeeds. Yes?
What you're saying is that management is no longer dictating strategy, but rather more and more percentages of strategy is being created from below, from the workers?
Absolutely. That's exactly what I'm saying. What I'm saying is exactly that. And if you look at Volkswagen today, I'm going to leave this off. If you look at Volkswagen today and you look at the way in which Skoda works today, in 1993 when Skoda came out with the Fabia, all it was a polo with a Czech skin. The Roomster is a Czech design. The people at Skoda, and I was there, I talked to them, the people at Skoda had this idea for a market, for a car that would meet a market niche, and that market niche would be a kind of young, hip, Eastern European, Central European, poorer country consumer that needed a car that would be very simple, very reliable, very roomy, and would allow for the kind of deliveries, whether it's the delivery of 3 children or the delivery of milk, that you got in Eastern Europe. And when the Roomster was created, it was not created through a platform. The designers in Skoda took parts from Seat, took parts from Audi, took parts from Volkswagen. I mean, I could go through which parts, which pieces of the chassis, which engine, and so on if you'd like. Trust me. They basically put it together like Lego pieces. Why? Because they had access to the components owing to the ecosystem created for the supplier network. The supplier network had become an ecosystem. Every supplier to all the other companies in Volkswagen Group put their roster of components up on the web. This component is a chassis. It has these specifications. This engine, this fuel injector. All of these components are capable of performing in this and that way in this envelope. If you want to know the person at Bosch who was head of the program to make that fuel injector, this is his name, this is his number, this is how many times we called on him, this is how reliable he was, etc., etc., etc. So you had the transparency of each of the company's supplier chain made possible by the network. In other words, suppliers themselves became transparent to one another because of the network. And it was because of that, that peer-to-peer communication, that you had the capability to move design from the center to the periphery. Questions? I'm just getting to the electric car now, but this is important to understand how companies now are developing electric cars in component networks which allow for a great deal more entrepreneurial initiative. Yes?
I'm trying to not be argumentative, but I just want to understand why the car companies took so long to become modular. I mean, this isn't something that existed in electronics. It existed in other fields.
Right.
Why were they such monoliths until the 1980s?
It's a wonderful question, and first of all, you're completely right that this is the way Toshiba was already working in the 1990s. Right? Most consumer electronics companies were already working through what they called modular principles. A part of the problem had to do with how long it took to percolate computer integrated manufacturing techniques to components that were heavy metal, so that you could begin to allow for suppliers to make stuff that wasn't just software. In other words, look, we have a company called Technomatics. We had a company called Technomatics in Herzliya. It was a wonderful company in the 1990s. Technomatics allowed you to simulate the manufacture of car parts on a computer before you actually bought the machine tools that would do the conversion processes. And that once you did the simulation, you actually could download the instructions to the machine tools based on the simulation that you did. Okay? In consumer electronics, most of what you were buying in a modular system was software. Chunks of code, maybe a chip. I once went to Motorola in the 1990s, and I talked to the guy who was making their first cell phones. He took out he said, "I love the smell of software in the morning." He said, So a lot of the modular principles that were being applied in consumer electronics were really assembling together chunks of code, small, very easy to manufacture things, and in some cases, huge, chips that required huge fabrication facilities, but chips that were being, in effect, turned into different things because of the different software you loaded onto them. So that became possible in consumer electronics. In heavy industry, it took a long time to have these techniques percolate down to the manufacturing to allow the kind of flexibility that allowed suppliers to respond quickly to new performance specifications based on prototypes that required a lot of bending of metal, heavy metal stuff, heavy manufacturing. So it's natural that industrial technologies like cars lagged consumer electronics because the components were so much more difficult to manufacture and required this kind of learning curve. But the way I would put it, I would sort of turn it around and say, the fact that this is happening now, even in the car industry, proves how universal these manufacturing principles have become. Even heavy equipment like cars, tractors, earth-moving equipment, and so on, are now being developed in the same way that the Skoda Roomster is being developed. Yes?
Is there an example of the ecosystem that evolved around competitors as opposed to a super company with subsidiaries and its suppliers?
Okay, here's an interesting question. I skipped a slide. I'm going to go back to it. Marshall's Garage in New Hampshire. So I drive my car into, I have this old BMW. I used to be in consulting, so I had a BMW. But then I left consulting, so it's an old BMW. And I had a problem with the so-called climate control. I go to Marshall's Garage in New Hampshire, and I say, Dave is the guy who runs the place. I say, Dave, tell me where the nearest BMW dealer is, because I'm sure that the module that runs the climate control, you know, that's the fancy word for heater and air conditioner, right, all in one module. Tell me where the nearest BMW dealer is, because I have to buy a computer, you know, like rather a component that'll swap out for the one that was broken. He said, I can fix that. I said, what are you talking about? You have a little two-bay station next to the public beach in New Hampshire, and you're telling me you can fix it? He takes me inside. He sits down at the soiled typewriter. He plugs into the International Automotive Technicians Network, IATN, which you can look up. He puts in my problem. You'll see I'm getting to your answer. He plugs in my problem, my year, my make. And he says, you know, not working. Could you tell me how to fix it? He says, they come back. He got 17 responses suddenly. 17 responses. You know, 2 were inconsistent. 15 were all the same. He said, that's probably it. He figured it out. He got in touch with the BMW supplier network, and he said, I can fix this. All I have to do is get my scanner to go into your computer, your master computer in your engine. I can figure out how to reboot this little component, and I can get the component from California in 24 hours. I said, how the hell can you do that? He said, no problem, you know, nobody is as smart as everybody, you know? So the groupware site was able, and you do this all the time, don't you? When you've got a problem with your software, you go to Google and you tell, I can't get my Adobe Acrobat to work with Windows 7, blah, 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 blah. Oh, boom, you know, something comes back to teach you how to fix the problem. But, and now this is the answer to your question, but it turns out that in order for that to have happened, something else had to have happened first. Remember I said, plug your scanner into the engine? Well, it turns out that in 1995, the EPA, the Environmental Protection Agency, determined that the port for every scanner be of a standard size. Why was it necessary for the port to be of a standard size? Why did the EPA want the port to be of a standard size? Huh? For what? Pollution, exactly. They wanted every gas station to be able to do an environmental test on every engine. So they had to have the port of a standard size. You know what happened? It turned out that because the port was of a standard size, you could create a standard programmable scanner which could download software from all the original equipment manufacturers. And so some guy who owned a 2-bay garage in Wilmot, New Hampshire, didn't have to buy a different piece of equipment for every line of cars. Now every garage in every part of the United States, in the world for all intents and purposes, is able to fix every car if they're prepared to buy the software. And software is always going to be cheaper than hardware. Why? Exactly. You made for one, you made it for a million, right? So you're always going, there's no marginal cost to adding a customer. Now, it's true if you have I don't want to sort of give you a principle. Oh, he said that, you know, software is cheaper than hardware. Look at Microsoft, it's more expensive than blah, blah. That's not what I mean. Obviously, if you can own a market, if you have a monopoly in a market, you can charge what you want. But the implication is here very, very clear And in fact, today, 70% of after-warranty repairs in the United States is made at small garages like Marshall's Garage. 70%, I'll say it again, 70% of after-warranty repairs in the United States is made at small garages like Marshall's Garage because they are able to compete with original equipment manufacturers. They actually came to a deal in 2003, actually. They came to a deal where the original equipment manufacturers were prepared to share everything but source code for obvious reasons, okay? But the specifications that allowed you to fix cars. So it comes back to your problem. How do you create an ecosystem? The ecosystem in this case was not created because some big original equipment manufacturer came out with particular specifications. The ecosystem was created because the government determined a standard which allowed for coordination and alignment among many independent problem-solving teams, entrepreneurial teams that were able to see an opportunity and take it. I'll add one more point. If people living in Israel don't understand the implications of this, you don't understand why this country has had 3,000 or 4,000 startups in the last 10, 15 years. Because Israel has been able to compete not because it's had access to the source code of big companies. There's no Israeli Bosch circa 1993. Israel has been able to compete because its small companies were able to detect an opening in a market where a standard has been created, or they saw an opportunity to maybe work quickly to create a standard, like ICQ is sort of the famous example of that. Okay, questions so far? Now we're getting to the electric car. Yes?
What happened to the American car companies? Are they different from Volkswagen?
That's a wonderful question. General Motors, which is going to be the subject of my discussion if I ever get to it, General Motors made a terrible mistake in the 1990s. Exactly the mistake that Volkswagen did not make. Volkswagen understood that the game is platforms and that from the reduction of their product offerings down to 4 platforms, they could create real efficiencies of scale if they went to cheaper places to manufacture, like Spain or Czechoslovakia. And from there, they went also to China, where they're number 1. General Motors were unable to break down the barriers between their various component companies. Now, by component companies, I don't mean companies that make components. I mean like Pontiac, they're divisions. They're divisions. For Volkswagen, this was not a small problem. To get people at Audi to say that they're going to share components with Volkswagen was a cultural shock to a lot of people. They had to be forced to break down these barriers and to share components. If Daimler-Benz had been willing to share components with Chrysler, Chrysler would be a different company today. But you could not get people at Mercedes to ever share components with Chrysler. And you also had a certain arrogance in Chrysler about certain, ideas about marketing that the Germans don't get it. We understand our customer. The Germans don't understand our customers. But in Volkswagen, what you had was the reduction down to platforms. Once you had reduced down to platforms, you could move to a modular strategy. It's like you can move from the erector set to the Lego pieces. And the Lego pieces would become available to all so that the economies of scale would be moved to the supplier and not to the original manufacturer, right? If you have a supplier that's making stuff for everybody, then you can actually create economies of scale at the level of supplier but the individual offerings that were coming out of the car companies were actually hitting micro-segmented markets and not big mass marketing programs. The GM problem was it had far too many platforms. It couldn't get its people to share components. It couldn't get Pontiac and Oldsmobile and Cadillac, Saturn, all of these various divisions to share platforms. And as a result, you had this proliferation of platforms. Instead of having 4 platforms, which Volkswagen had, GM had 14. And the cost of complexity in GM just defeated them. I'll come back to this if you want in the questions. I have 15 minutes, and I want to get to the electric car. Now, the ecosystem that created the Chevy Volt is very much like the one that created the Roomster, the Skoda Roomster. There was a champion inside of General Motors, a guy named Bob Lutz, who was a product development guy. He had a younger colleague by the name of Tony Posawatz, who was an electrical engineer and also an MBA from Dartmouth, and they began a product program called the Chevy Volt. They knew they had to hit the market quickly. They knew they had lots of components to create. So they took an engine from Opel. They took a steering column from Chevy. They took brakes from other hybrid programs. They took an existing chassis from the Delta program. They put together an electric car in a way that was unprecedented in speed and innovation. Innovation is integration. Innovation is integration. I'll say it again. Innovation is integration in a networked world. And once they had put the car together, they had a problem that presented a huge opportunity. The idea behind the Chevy Volt is this. We know that at existing levels of technology, we cannot make a battery-powered car that's going to take a family of 5. We cannot make that car go more than 40 miles on a single charge. Okay? I know that there are other car ideas with smaller cars that go further. The Tesla goes, they say, 150 miles. There's a new Nissan Leaf that thinks it can go 100 miles. We'll see. Someone from Better Places here, I'm sure they're going to have something to say about that. Just a moment. But this is America, family of 5. You need to be able to get a car of a certain heft. And the only range you can get out of a battery with existing lithium-ion technology is about 40, 50 miles. So the people at Chevy Volt said, all right, we're going to take that to be the case. But you know something? %, 78%, if you take the Department of Transportation statistics, 80% of Americans don't drive more than 40 miles a day. They don't drive more than 40 miles a day. They're only going to need to go more than 40 miles a day under extraordinary circumstances. And when they go more than 40 miles a day, they want to be certain that they're not going to break down in some kind of stop-and-go traffic on the New Jersey Turnpike in a driving snowstorm on the way back from Grandma's house. They don't want to go looking for a place to fill a battery that takes 8 hours at 110 volts and 3 hours at 220 volts. They want to be able to be sure that they can recharge their battery and go on. So they said, you know what? I'm going to put an engine in the car This is not a hybrid. This is not an engine that's going to drive the wheels. I'm going to put an engine in the car that recharges the battery. The engine I'm going to take is one that's already proven. We took it from the Opel. It's a 1.4-liter engine, indestructible. And this engine is going to extend the range of the car to 300 miles, which is more or less what you get from a fill-up of gas. You can do the translation into kilometers and liters. I haven't been that. I have to go to the Ulpan and figure out how to do that. So the problem of range extension is solved. We use an existing gasoline infrastructure, 220,000 gasoline stations in the United States. We're not going to turn them all into electrical charging stations or battery swapping stations. Pache, better place. We'll talk about this after. We're not going to do that. What we are going to do is use the existing technological infrastructure to do something great. And what's great? It's not that we're all going to be George Clooney. Great doesn't mean we're going to make the earth stop smoking. Great is that you're going to go 2 to 3 cents a mile 80% of the time instead of 13 to 15 cents a mile 80% of the time. Because the cost of running an electric car 2 to 3 cents at a time, 2 to 3 cents a mile, is going to be so obviously advantageous that people are going to buy this car in the same way that they would refinance their mortgage if interest rates dropped 2%. Makes perfect sense. Just a moment. At that kind of cost saving, you're saving about $1,500 a year. Because you're going on full electrical power 80% of the time. Or let me put it this way, 80% of the people are doing it almost all the time. Okay. So, we're doing it because of the component networks that make the car plausible. We're doing it because we understand that the consumer is solving a problem within the context of an existing infrastructure. So far, so good? Now here's a problem. What happens if this is such a good deal, if people buy the Chevy Volt at the same pace that they buy the iPhone? And you have hundreds of thousands of such cars cruising home in Raleigh-Durham, North Carolina, at 5 o'clock in the afternoon, and all plugging in. What happens? Well, what would happen if 200,000 people turned on a massive air conditioner all at the same time at 5 o'clock in the afternoon in Raleigh-Durham? You'd burn out. I mean, actually, I'm over-dramatizing a little bit. What you'd really have is problems on the local level. You'd have brownouts for sure, but you have a real problem of transformers getting overloaded at the local level. And one of the things they discovered, Oak Ridge National Laboratory did a really interesting study. If every American home had an electric car, the amount of energy that you'd have to produce to charge up batteries is actually only 10% more than we have today. Because the grid is able to charge that many cars. If you just take the absolute amount of energy produced in the grid and the absolute amount of demand you have if all 300 million American cars were charging on the grid. But if only 25% of householders had electric cars, and they all plugged in at 5 p.m., you'd need up to 160 new power plants to charge those cars. 160 new power plants to charge the cars if only 25% were plugging in at 5 p.m. What's the problem? The problem isn't the amount of power. The problem is the distribution and the sequencing of the charging. Right? Clear? So the people at Duke Energy and the people at the Chevy Volt project and the people who are working the system know that this is a huge problem. What happens if you build 160 new power plants? Duke Energy can manage it. Duke Energy, or, they can build another coal-fired plant, another gas-fired plant, but then what happens? It's not environmental. You're also burning fossil fuels that cost more, right? And so eventually the cost of burning those fuels is going to be reflected in the cost of energy. The critical problem for the electric car is to take energy from renewable sources and bring them down to the car when it's needed, the same way that you plug in an iPod or an iPhone and download a program when it's needed from an available server. The problem is the switching in the grid. The problem is the information that tells the grid how to switch and where to bring energy from. Let me see if I can make that clearer. Let me see if I can just make this clearer, and then I'll take the question. You want to have cars that are able to say, fill my battery now or I can wait till tomorrow morning. Or a car that's able to sync your schedule, you have an Outlook schedule. The car should know what your schedule is. No, I don't have a PTA meeting tonight. I don't have to go out tonight. I don't have to get my car filled up until, 3 a.m. I don't have to charge my battery to 3 a.m. So don't charge me now, charge me later. You need to have cars able to say this to the electric grid, and you need to have a way of syndicating all this information. You know what I mean by syndicating? Assembling all this information and bringing it up to the electric grid. You also need a grid that's able to say, take power from renewable resources when possible, when the wind is blowing in Texas, when the sun is shining in Nevada, when there's excess capacity in Niagara Falls because it's the middle of the night and a lot of that energy is just going to waste. That's really the problem. And then the question then becomes, going back to Marshall's garage, going back to the problem of how you get people synchronized around this problem. What are the standards for the hardware? What are the standards for information upload? What are the standards for the format in which that information is presented to the power companies? What are the standards by which power companies are billing when you're filling up at one station or filling up at another? I mean, if you drive from here, if you're in Raleigh-Durham, and you get an energy bill, you drive up to Washington, D.C., you plug in your car. You want to be able to see the amount of energy that you're downloading on a single bill. So there has to be format for sharing information between Duke Energy and the power company in Washington, D.C. So that what you are downloading in electrons gets reflected in your energy bill in Raleigh-Durham. You need standards for managing information on the grid, and you have 3,200 power companies in the United States 3,200 power companies, I can tell you, who don't have the most advanced information technology professionals. So, what is the ecosystem for that network? It's an ecosystem driven by standards for hardware in the car itself, like the plug for that engine computer, for information upload, for the formatting of the information, for billing, and for managing information in the grid so that the various power companies know where to take power from and when to send it. So far, so good? You following? You had a question.
Yes. What are the numbers of scheduled sales of this car? Because I heard that it wasn't big numbers.
The Chevy Volt is going to have 10,000 production cars in the first year. It's going to scale to 40,000 in the second.
So we're not talking about big numbers like 25% of Americans driving electric cars.
No.
It's not for tomorrow.
No, but it could be 5 years from today. I mean, you're talking about a revolution in the way in which cars are being manufactured, a revolution in the way customers are going to demand cars, because the economic and environmental, the cool factor, the environmental factor and the economic factor in electric cars is so clearly ripe for a takeoff. But in order to get that takeoff, in effect, what you're doing is driving the development of all of these networks. Because the actual amount of money that it takes to produce this little thing is trivial. The car itself is like a laptop. The margins in car production are going to be trivial. What's going to be big, where the premiums are going to be, is in the entrepreneurial companies that are contributing solutions that allow for the scheduling, downloading of electrons and bits of information into this mobile device. Let me see if I can make this a little more clear. There are basically 5 components in this ecosystem. There are the battery makers and the integrators. There are battery farmers. By the way, I just talked to somebody on your faculty who is involved with a company who's thinking about this. What are battery farmers? It turns out that the batteries in electric cars may have a life of about 5 years, after which they don't get you 40 miles anymore. So if you have to swap a battery, by the way, this is an expensive problem. It may be a problem for the Chevy Volt and for other electric car makers. I'll come back to that. But if you have a battery that's no longer good to run a car, it still keeps 75% of its charge. What happens if you create a whole farm of used batteries? Suddenly you have the capacity to store a tremendous amount of renewable energy that can be given back to the grid. So that's a whole new way of imagining the grid. You have to have companies that are able to manage the technology of bringing information from cars to the grid. How do you bring information from cars to the grid? You do it through telecommunication systems. But you have to bring it in a particular format. So you have builders of the smart grid as well. You have connectors which allow cars to actually download electrons and information about refueling. Let's call it recharging. All of these together include also new part suppliers. One very interesting thing about electric cars, just think about it. Air conditioners in cars today. Air conditioners are driven by? No. What are air conditioners driven by in cars today? Belts, right? There's a lot of components in cars that are getting their power out of the engine directly. Think of all the things that are being driven by belts. Hydraulic, steering columns, et cetera, et cetera. All of these components now are going to have to be changed to electric dynamic systems, right? You're going to have an electrical air conditioner. You're going to have an electrical steering column. You're going to have an electrical braking system. No, Toyota has not solved these problems. They're working on them.
What power is the air conditioner in the Prius?
The engine. The Prius is a hybrid. The Prius is a car that runs an engine driving the wheels and driving other components. The Prius is not a fully electric car. They're working on a fully electric car, which they may be releasing around the same time the Volt is being released, on the same principle with an onboard engine to act as a dynamo to refill the car. But that's also going to be a problem. Think about having an engine that's refueling, recharging your battery. Suddenly you've drawn the power down. We were talking about this before. You've drawn the power down so that you can't go any further unless the engine kicks on. And you come to a stop sign and you hear, it's a little disorienting. So you need to have new components that are capable of monitoring and regulating the speed of the engine to the speed of the car so that you don't freak out drivers. What happens if you plug in a car in 30 below zero temperature in Michigan? How do you get a battery to start a car? How do you start driving an electric car at 30 below? You need to have a way of segregating the battery, warming it and cooling it. The Chevy Volt people talk about the battery as a fifth passenger because it's got to be made comfortable the same way a passenger is. So I'm going to just speed through this now. The standards for hardware, good example of this is the plug. Yes, do you have a question? Go ahead. Sorry?
Can you give me the guarantee that I can use this rechargeable engine more than 5 years or more than 6, 7 years?
The problem isn't the rechargeable engine. The rechargeable engine for most, you know what the biggest problem with the rechargeable engine, the charging engine is going to be? That people are going to forget to change the oil in it. What happens to an engine which never goes on and you just haven't changed the oil in it for a year? This is a problem that people with these kinds of cars are going to have to figure out. The problem is the battery itself. The battery itself is probably not going to last more than 5 years. This is going to disappoint a lot of people because it's going to be very expensive to fix. But you know something? It's a little like, this. After 5 years with new technology, you sort of understand that you're on the edge here. And I think GM can do something about it. I'll come back to it in a moment. Okay? I just want to finish this. I want to leave time for questions. We have till 7 o'clock, but I want to leave time for questions. Standards for hardware. There's already a standard for the charging plug, which has created a whole new group of companies. The leader of these this new market space is called Colomb Technologies, which is doing the work of recharging electric vehicles in downtown open spaces. We have the telecom companies that syndicate information. Has anybody here heard of GM's company OnStar? OnStar right now is a kind of collision reporting system. It started as a GPS system, right, where GM was offering its people a chance to do GPS positioning. OnStar today is, in my opinion, positioned to be one of the biggest telecommunications companies in America because it has the capacity to create the standards that syndicate information from electric cars to the grid. It is a telecommunications platform made specifically for cars. It's baked into 6 million cars right now on the road. OnStar is already monitoring the performance of cars so that if you have a ball joint that's faulty or if you have a fault in your electrical system, OnStar will send you an email at the end of the month and tell you you have to change this in your car. Now imagine, just think about the space here. Think about the space. If you are a company that's syndicating information from the performance and routing of millions of cars, what do you look like? What company do you look like if you know the traffic patterns of millions of car users? Huh? I don't know what that company is, sorry. Web analytics, exactly. It looks like Google. It looks like Google Analytics. If you know, just think of the marketing potential. Think of how much money you could make from marketing the information that you gather knowing the performance and routing of cars. Think of how you can stop collisions. Think about how you can stop thefts. Think about how you can know where your kid is on Saturday night. Big Brother is sort of here. And the biggest company I think you're going to hear of in this ecosystem is a company called GridPoint. GridPoint is a $260 million launch, money from Goldman Sachs, money from lots of private equity funds. And GridPoint is now already working with the Chevy Volt to create an information storage and distribution format for the electrical companies, and is at the same time working with electrical companies to manage the development of smart grids. So don't forget, the real problem is, how do you get the grid to get smart enough to answer the cars that get informative enough? Right? That's the problem. How do you get the grid to get smart enough to bring renewable sources of energy down to a bunch of cars that are informative enough to tell the grid of their charging patterns in some aggregated way? That's the problem, and that's the opportunity. So the solution is also a place of real contention. If I'm OnStar, I don't want GridPoint baking stuff into my console. GridPoint, the CEO of GridPoint, Peter Corcel, told me, I want to bake stuff into the console. GM wants to create the standard, the same way Microsoft wants to own the standard for the operating system on a laptop. GM wants to own the operating system that reports out information about charging patterns to the network. GridPoint is saying to Toyota, you want GM controlling this? You want GM going to Ford? You want GM to control the standards? Come to us. And this is going to be a fight. And the fight is going to be over whether OnStar can get big enough, fast enough to become the de facto standard, like iTunes. Or other companies say, no, we're not going to work with you. We want a third party, and a new space comes in. A new space is created, and new entrants come in. GridPoint is a very good example, and I'll just close by saying one last thing. What is GM's biggest problem? The issue, we're talking about networks, developing design in networks, for networks. There's another last network that I think is part of the solution here. What is GM's biggest problem? You're GM. You've had 20 years of lousy cars. You were bankrupt. You needed the American government to bail you out, and the American government now owns 65% of you. You have a new car launch, which is potentially the iPod of a new space. What can kill you? Why will sales not be great? What are the PR problems you're going to get at GM? Okay, here's a case. It's an interesting question, but I think that problem is not as serious as others. I mean, huh? No network? What do you mean?
It's inconvenient. There aren't enough people adopted it, so it's not as useful yet. It's like
No, you have the car, you have the plug. You can buy a plug and plug it in your home. You can have an infrastructure slowly building at your public space, but you're anyway only driving 40 miles to and from work, so you can probably get there and back. You have an engine that kicks on, so you can probably, it's true, only 50% of Americans actually have a garage. The others live in apartments, they live downtown, so they're going to need all kinds of places where there are public opportunities to plug in. And that's where Coulomb Technologies takes first place, and that's why the coming to a standard for an electrical plug is not a small thing. It took for the cell phone industry, it took only until this year to come up with a charging standard on the USB standard. It took that long because the EU forced them, for environmental reasons, to all come together on the USB standard. Okay, if you're GM, what's your real problem? How can your sales really go down? How can you kill yourself? It's a new technology after all, right?
It's like spinning circle, and enough customers to give the industry enough power to invest in the infrastructures and buy and build and increase infrastructures, so more customers can buy additional cars, and it's something that feeds itself.
You're thinking too much like business strategists. I think like consumers for a second. The new technologies may be very expensive. In other words, they may not be as cheap as you thought. What could make them more expensive than you thought? What? What could happen? They'll be breaking down. The car will be breaking down. What happens if you're driving all these new components, these first generation components, electrical dynamic components for air conditioners, electrical dynamic components for steering columns, braking systems that have to capture energy when you brake and then give it back to the car when it starts up again. And so all of these components are very new. The battery itself, lithium-ion batteries, right? Lithium-ion batteries are, very difficult to monitor. The battery pack, it turns out that the lithium-ion battery cell, well, first of all, you know what these batteries are. These battery packs in electric cars, they're basically 200 to 300 batteries like the ones in your laptop, all stacked together. And they all have to communicate with one another. And the weakest link in the chain will determine the power dynamics of the entire battery. So a battery that's supposed to give you 40 miles is giving you 20 miles because there's one cell out of 300 that's misbehaving. There are so many ways in which these components, which are not yet solid-state components, right? Because one of the things we know, integration is innovation, right? Integration is also what builds quality and cuts costs. Once you have integrated components, solid-state components, they're much cheaper and much more reliable than stuff you have to put together with wires and algorithms. So what happens in this situation is that one of these components fails, and what happens then? Blogosphere, word of mouth, GM, I knew it, what are we talking about? This company can't shoot straight, blah, 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 blah. The program is dead. And they had a perfectly good product that dies because people will have no patience for next generation technology from an old generation company that's already proven it can't even make good internal combustion engine. So what do you do if you're GM? What do you do? What kind of network do you create in order? Huh? Single words don't mean anything. Make an argument, somebody. What do you do? Huh?
You work with your competitors, to come up with, better products, have other companies launch similar products too, so that people can compare you against other.
Well, that would be ideal. It's just that, most competitors don't like to do that with one another, not when they're going for the same customer. What would you do if you're GM? Exactly. You use social networking to create a community so that your first users are thought to be and made to feel like members of a first-generation technology community that will feed information back to GM. And there are ways of doing this. Promise them a complete refund on their first car when they trade up to the next generation. Give them a website where they can share product information with designers of next generation technology. Give them the possibility of showing GM designers what real use cases are by people who are in unorthodox situations. Huh? We already have shares. We already have shares. Huh? It's not such a bad idea. Actually, I hadn't really thought of that. I'm not sure what the SEC would say about that. But I think look, clearly, there's a fourth network here, and that's the network that a consumer company creates with its customers. If GM is going to, or any company is going to advance into such next generation technology, it's very important to make your customers part of your design team. It's very important to raise their level of participation and, in a way, lower their expectations without making them feel like, as they say in Israel, friars. Right? That's the real interesting opportunity. Whether GM does this, I don't know. I've actually been talking to them about it. But I think there's a fabulously interesting case here for how you manage the introduction of new technology. But one way or the other, the ecosystem of this car is going to revolutionize grids, manufacturing, information networks, telecommunication networks, and all the other parts of standards-driven networks. And, in my view, there are a lot of opportunities for people in this room as well. Anyway, thank you very much. I have a few more minutes for questions. The truth is, unless Simon intends to take me out, immediately I'll take as many questions as you have patience for, because I'm not going anywhere. But anybody who wants to leave, please feel free. Yes? You want to speak up so people can hear you?
By 2020, China should become the biggest car market in the world.
Right.
If I don't go wrong.
Yeah.
And so there's a big opportunity for electric cars to be produced there. But what options are I think the biggest Chinese car producers actually going to go for in terms of engine to produce? What do you think? Are they just going to make a simple fuel engine, or are they going to develop anything? There's a big market.
China is still thought of as a country of consumers and not a country of car designers. It's changing. It's changing. Karl Hahn, the guy who bought Skoda, who was the chairman of Volkswagen, whom I've known over the years, told me after I sent him this piece from Inc. magazine, he said he thought that China would actually be leapfrogging American car designers in the electric car market, you know, in this decade, in this coming decade. I think it's premature to look at the car industry that way. Or let's put it this way, as much as I admire Carl Hahn, I think he's missing something. It may be true that the actual manufacture of batteries, the manufacture of these electrical dynamic components, etc., may be originating with Chinese suppliers in the Chinese car ecosystem. I believe that could be true. But the management of the networks, where the real money is, the development of the grid points, the development of the OnStars, the development of all the marketing companies and all the derivative companies that you get from the information that flows up to these networks, manages the grid, the Cisco systems of the grid, the companies that make the switching, the companies that solve the problem of interpreting the information that determine the switching. Those companies require a tremendous amount of what I like to think of as technological freedom, entrepreneurial freedom. Whether China is able to compete in those knowledge-intensive and creative industries, I'm truly not in a position to say. I suppose if Czechoslovakians, if Czechs rather, Bohemians, can design cars that are as good as anything the Germans did, it's quite possible that there are going to be smaller software solutions companies in China that are capable of solving problems we used to think had to be solved in Aspen or in Herzliya. I don't know. But I do know, what I do know is that the car industry is not a hardware industry anymore. The car industry is a software and telecommunications industry, just like the consumer electronics industry is. And whether China can compete successfully in those market spaces, I'm really not sure. I don't know. One more question. Yeah.
My question is, why not? General Motors has been advertising the Volt for a few years now. They have billboards in Detroit for 2 years, 3 years, advertising a car that doesn't exist.
No, it does exist. I drove it.
Okay, but it's
Excuse me.
But we can't, right? So
No, it's being launched in November.
okay, it's being launched in November, and the signs, I saw billboards in Detroit in 2006 saying it's coming.
No, it was. Excuse me, you didn't see them in 2000. The Chevy Volt as a program did not exist in 2006. Maybe 2008 you can say.
No, maximum 2007, because I know when I was in Michigan.
Okay, 2007 perhaps.
And I had representatives from General Motors coming and talking about the Volt.
Okay.
So, at the University of Michigan, giving Volt talks on how this is going to revolutionize the system.
Right.
And this is when gas was at $40 a barrel before it hit the 150 and then went up.
Right, okay.
But my question is, and it's not important in 2006 or 2008, they were advertising it long before the car was available. And
Yeah.
it's our next big product.
Right, okay.
But they had an electric car 10 years ago.
Right.
Why didn't it work? What changed that made it different? That
Because they were managed by a bunch of princes. They were managed by a bunch of people who thought that they could just ride the SUV market to kingdom come. They were managed by, General Motors management is not going to gain any great credit from me. When I covered the auto industry, if General Motors had done the things that Volkswagen did in the 1990s, they wouldn't be a basket case today. But General Motors actually had something called a crisis. You may not have noticed, General Motors went bankrupt. General Motors not only went bankrupt, but they were taken over by the government and they spun off about 60% of the company. And what's left in General Motors are at least certain old line technology cars that have a chance, plus the Chevy Volt, which has a huge chance. So if look, Xerox also screwed up, but Xerox actually created the graphical user interface that Apple made. It's possible that GM, having created the Chevy Volt and having solved the problem of the battery pack and solved the problem of all kinds of other things that they're doing, will not be the ones to actually, market the technology. I'll tell you one thing, the Chevy Volt team will be a company whether GM exists or not. Because, to go back to that pyramid and what happened to the pyramid, the Chevy Volt team as a global enterprise within GM is going to survive any destruction of GM. Because the proprietary technologies they have for the Volt are fabulously valuable. They have a battery testing station in Michigan, which is a one-of-a-kind laboratory in the world. They have what they're doing with OnStar to develop reporting formats and reporting protocols to telecommunications environments, whether OnStar exists as a GM company or exists as a spin-off. It doesn't really matter. OnStar as a company will continue to exist, or whoever buys OnStar will acquire the intellectual property that OnStar represents. So, that's, sorry, but what's the question behind the question? I think there's a... Well, it was successful with Tom Hanks. I mean, with all due respect, the EV1 car, I think, had a range of 15 miles. It was like a golf cart. No, but if you put an engine on a car that can only go 15 miles, I think they were still using nickel hydride batteries. They didn't have lithium-ion battery technology yet. They didn't have the capability of building a 40-mile range into the car. At 40 miles, you have something because you have a car that actually goes as far as most people go in a day. That's huge. 15 miles is no more than what some, I don't have to characterize it, but it's almost, a 15-mile car is what a movie star does to go to the deli and back home. That's not a vehicle that's going to be a market success.
I'm going to stop.
Yeah, okay.
I want to thank Bernie. Thought leadership, right?
Thank you.
He's still here.
I'm still here. So anybody has a question, I'm still here.